some water. All right, recording now. So today's topic is gonna be rational functions. All right, we kinda saw what are rational functions in the previous class, but we didn't really talk about it. We didn't really expand on what are rational functions. We are going to do that today. Let's begin with what is a rational function. The easiest way for me to explain that is with a couple of examples. So here in the screen, I am showing you 3 examples of rational functions. All right. Now, why do we call them rational functions? Okay, these are called rational functions because these are the ratios between two things, right? In this case, two functions, right? So we have one in the numerator, one function, and we also have another one in the denominator. This is a ratio, right? By the way, did you guys remember what a ratio is? No? Okay, a ratio is a division. 2 over 3. That is a fractionary, right? 2 over 3. Let me write it here. Here, all right. So this is a ratio. 2 over 3. Because we are dividing 2 and 3. 2 divided by 3, right? This is a ratio. Ratios are divisions. Now, since you know, hopefully you guys know that every fractionary, no matter the number on top and no matter the number down, every fractionary is a division. We call ratios. The easiest way to identify a ratio is by looking for a fractionary. Fraction on. This is an n. This is an n. Sorry, I'm writing with my mouse, so it is awful. Sorry, guys. This is an R ratio. There you go. So in here we have 3 ratios, 3 fractionaries. All right, is that better now? Cool or not? Okay, some of you are moving your head, so I'm assuming yes. All right, beautiful. So what is the difference between what we call a ratio and these functions that are rational functions? Pretty simple. In a ratio, just like my example in this one, look, take a look at my example in this one. The ratio was compounded by 2 numbers, 2 and 3, the one on the numerator and the one on the denominator, right? 2 numbers. A rational function has 2 functions, one in the numerator and one in the denominator. How about that? Now, those 2 functions have to have some characteristics, right? Number 1, the first characteristic is that the functions are polynomials. Do you guys remember polynomials from the last class? Right? This is a polynomial of degree 2, another polynomial of degree 2. Here, in this one, we have a polynomial of degree 3. Here, a polynomial of degree 2, right? Degree 2 and degree 4, right? So these are polynomials. That is the first characteristic. Every single one of our rational functions have to have a polynomial on top and a polynomial down, all right? This is gonna be the real definition, right? We call them P over Q, right? Now remember, these letters in front of the parentheses, right? These letters, so the R, the P, and the Q, these letters are simply the names of the functions. Simply the names of the functions, right? So the one on the numerator, the one on top, the function on top of the fraction, the numerator, right? We call it P. That is the function P. And the one in the denominator, so the one down, we call it Q. That's it. So let's take a quick let's make a quick question here, right? Everybody in the chat, please, in the chat. I want everybody to answer in the chat, please. Tell me, guys. Looking at the second function, so the one in the middle, right? This one that I have, that I'm showing here, the one that I have my mouse on, this one. Are you looking at this one? All right. Tell me, guys, tell me. What is the function P? In the chat, please. Which one is the function P? According to the second one. Which one is the function P? Everybody, please, everybody in the chat. Thank you, guys. All right. Oof, look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oof. All right. A lot of people are answering. Beautiful, guys. Beautiful. Thank you for participating. All right. All right. All right. All right. All right. Well, you guys are correct. Well, you guys are correct. Now, look, some of you in the chat, some of you said, this is the answer, teacher. Let me just write, take a little piece here. Some of you said, this is the answer, teacher. X3. And some of you said X3. It doesn't matter which one. I mean, I understood what you wanted to say, guys. So this is correct. This is also correct. It doesn't really matter. You are correct. The function that we call p is the one that is on top of the fractionary. In this case, in the second function, the, the function p is x cubed, x to the third power, right? Beautiful. The one down will be the q, right? Okay, now the function q, let's take a look at the characteristics of the function p and q. All right, p and q, as I said, p and q are polynomial functions, right? So these are polynomials that have a degree 1, degree 2, degree 4. The degree matters, right? But also take a look at the function q. Again, the function q is the one down. The function q is not the zero polynomial. So q cannot be 0. That is because if I put a 0 here, what we have is a function divided by 0. And we cannot divide by 0 in mathematics, right? So that is the reason why q cannot be 0. Please, that is one of the main characteristics of a polynomial. Go ahead and write it down somewhere, please. The function on the denominator, so q, cannot be equal to 0. It has to be something different. 1, 2, x to the 7, I don't know, whatever. Different than 0. You guys good with this? Beautiful. Thank you. Man, I love it when you guys show me your thumbs, right? You give me a thumbs up. I love it when you guys do that because I see that you guys clearly understood. All right, beautiful. Now, this is how we recognize rational functions, right? Now, let's talk about the domain of a rational function. The domain here. The domain of a rational function. Now, some of you, I am sure about this. I am sure that some of you might be saying that you don't know what a domain is. So even if I explain what is the domain of this function, you guys will be lost because you don't know what is the word domain. You don't even know that, right? Okay, don't worry. I'm going to explain that in the easiest way possible. With a couple of drawings. With a couple of drawings. There. All right, so let's take a look at this function, guys. Let's take a look at this function. I don't know, this. There. Okay, so hopefully you guys have taken a look at the screen, right? And you guys can see my awful Cartesian plane. This is awful. This is a really bad Cartesian plane. You'll have to excuse me, guys. I am doing this with my bare hands, right? And then the function is going to be the blue line. Now, take a look at this. I am not saying that this line continues to infinity, right? I don't have the arrows in there. No. No. Let's draw it again. There. I am not saying that, right? This line doesn't continue to infinity. In fact, this line begins in this point and finishes at this point, right? That is going to be my function. Now, how do we recognize the domain? Let's talk about what is the domain first. Domain is just a set of numbers, un conjunto de números. That is what a domain is. A lot of numbers, Just like any domain, we can write it like this, domain. So maybe the domain are the numbers 1, 2, 3, 4, 5. I don't know. Maybe that is the domain. And then dot to show infinity, right? Maybe that is the domain. I'm not saying this is the domain here, right? This is not the domain there. It is not the domain there. This is just an example of what is a domain. A domain is a set of numbers. A lot of numbers. All right? Let's erase this example here. All right, so let's think about what is the domain of our blue function, the one from here. The domain will have to be from one number in x And you guys can see that this function begins in x. It begins exactly at this value. And finishes, this function again, finishes at exactly this value. Right? So those two values are going to be our domain from one to the other one. Now let me put signs in here. Let's say this is 1, this is 2, so this is 3, right? I'll say 4, 5, 6, 7, 8. All right, so 9, 10, whatever, right? So what would be the domain there? What will be the domain? Now, I'm gonna do it with this block of notas, block de notas, right? Because I hate, guys, I hate having to write with my mouse. The word is, my handwriting is just awful when I do it with my mouse, all right? So I'm gonna have to do it here. How do you write the domain? Okay, the domain is every single one of these numbers in the x variable, every single one of these, from the 3 to the 8, right? So now you're thinking, okay, the domain, let's write it down. Let's write domain. Domain. Okay, the domain are these numbers. 3, 4, 5, 6, 7, and 8. And then close the corchete. Again, remember, this bracket, this weird bracket, this corchete, is the one that we use for sets, right? So if you do something like this, if you do this, domain, domain, main. If you do the domain like this, 3, 4, 5, 6, 7, 8, then the domain is wrong, all right? Simply because you're using the wrong parentheses. Remember, in mathematics, we need to know how to write down properly, right? Beautiful. Beautiful. Now, is this domain correct or is it wrong? That domain is wrong. That domain is wrong. And the reason is because I said the domain was every single number that I can find between 3 and 8. And between 3 and 8, there are a lot more numbers than these 5. 3, 4, 5, 6, 7, 8. Here I said, what, 6 numbers? The domain are more than these 6 numbers. We have, for example, this one in the middle, 3.5. Huh? We forgot about the decimals, huh? Or maybe one really, really, really close to 8. There, 7.999. I don't know. That one is also part of the domain. And I didn't write it here. Look, the 3.5 doesn't appear there. And the 7.999 doesn't appear there. So clearly, this is a mistake. This is a mistake, guys. So how do we say that the domain are every single number from the 3 to the 8? How do we say that? Well, we just say it like that, domain. All real numbers from 3 to 8. And that is it. We did it. We did it. That is the domain, guys. Look at that. Domain. All real numbers, again, un momentico en español. Si no se acuerdan, muchachos, esta palabra real numbers, estas dos palabritas, números reales, esto hace referencia a todos los números que sabemos utilizar, ¿no? A los números que conocemos, pues, ¿cierto? Los números reales, ¿no? Todo, decimales, racionales, con decimales o sin decimales, con repetidos o sin repetidos, todos los numeritos que existen. Pero no son todos en realidad, ¿no? Son todos los que hay entre 3 y 8. All right, that's it, guys. That is how we write domains. That's it. Tell me, did you get the idea or not? Cool. Thank you, man. Some of you are saying yes. Beautiful. All right. Let me show you another example about the domain, and you guys can help me with the domain for this one, right? Now, you know what? Let me just do the example myself, and you guys are going to help me in the next one. We're going to do a third example. All right, let's take a look at this. Let's take a look at this. What did you guys think is the domain of this function? Let me do it in blue again. What? Let's say this. There. Again, I don't have the arrows, right? If I had the arrows, guys, this is important. If I had the arrows means that these lines continue to infinity. So if I move this down, this line will continue there and will continue there, will extend, right? That is the idea of the arrows. That is the idea of the arrows. And that happens sometimes, right? So if that is the case, the domain here is just all real numbers without one number to the other one. No, just all the real numbers again, because this comes from negative infinity all the way to infinity. All the numbers, right? But no, let's do it a little bit simpler. Let's erase these arrows. And let's say that for this, my function simply begins here and finishes there. All right? Now, I need to know where here and where there are. So here is this. Let's say there. And there is this one. I know. Let me do it a little bit better. There. A little bit better. There. Okay? So, of course, we're missing one, a little bit of marks here. Let's say this is -1, -2, -3, and -4. So this is -4, right? And here we have 1, 2, 3, 4, 5, 6, 7, 8. This is the number 8 as well. Okay? So what would be the domain of this? Okay, so we know the domain are every single number between this and this. So between -4, sorry, it looks like a 1. So let me just erase it and rewrite it again. -4. There, better. So we know the domain are every single number between -4 and -8. Of course, we can do this. We can just count the numbers, right? We can say -4, -3, -2, -1, right? 1. We can do this all the way to 8. We can do that. But this is a mistake because we are not having into account the decimal numbers, right? So what happens with this one? Right in the middle. -3.5. Or this one, right in the middle. 1.5, right? Or this one, really close to 2, really close to 2. 2.1. We don't have those decimals there, so we don't write it like this. This is a wrong domain. We have to say that the domain are all real numbers, real numbers from, and this is where we say from what number to what other number. So these are from -4, right? From -4 to 8. So that's it, guys. This is the domain. All real numbers from -4 to 8. That is it, guys. That's it. That is what the domain is. Domain is the set of all the numbers that the function can take for x. Of course, we can do the same analysis, but for y. So we can say in y, we have from here to there. So these are all the values we can take in y. And that is called the range, but we're not gonna study that today. So let's just focus our attention on the main. Maybe the last class, maybe the next class, hopefully, right? Hopefully. All right. It is your time. It is your time, guys. Your time to practice. Let me erase all of these. And you guys are gonna write down what is the domain and what is the range of the function that I'm about to show you. Ready? All right, ready. Let me erase all of these, the red line. Let me just erase all of this. There. Okay, let's erase this -4, this 8. This is going to be the function. You guys ready? All right, here it goes. Let's say what? There. A weird looking ellipsis. Weird looking ellipsis. Now, of course, maybe you need guides. So let me show you the guides, right? This is from this, and this is to this. All right, there you go. Please, in the chat, guys, in the chat, tell me, what is the domain of that function? What is the domain of that function? You can count these, right? You can count these. 1, 2, 3, 4, 5, 6, 7, 8, right? You can count these. All right, a lot of people are answering today. Beautiful, beautiful, beautiful. Thank you. Excellent. I appreciate that you're not being lazy and you're not just writing these. 3 to 8. No, that's not the domain, right? That's not the domain. 3 to 8. That is not the domain, right? 3 and 8. That is not the domain. No. Write it down completely, right? Domain. All real numbers from 3 to 8. Hey, esto fue de suerte, ¿no? Mira que en los dominios que hicimos siempre nos quedó el 8 al final. Eso fue pura suerte, ¿no? No vayan a pensar que todos los dominios terminan en 8. No, no. Si yo hubiera hecho el circulito un poquito más largo, si yo hubiera hecho el circulito hasta por aquí, pues entonces en realidad el dominio hubiese terminado por aquí arribita. Mira, de pronto justo en un decimal. Por ejemplo, en 9 punto algo. Ok, pues bueno, pues termina en 9 punto algo. ¿Sí? Eso era hasta 8. All right, guys. Beautiful. So that is the idea behind domain, right? That is the idea behind domain. So let's take a look at what is the domain of our rational functions. What is the domain of this function? Take a look at this. The domain of rational functions is the set of all real numbers. So that is good. That's good. That's good because we know the set of all numbers, right? All we have to do is this. All real numbers. Domain, all real numbers. That's it. That is good. So far, that is it. All real numbers. But take a look at this. Except, oh man, we have some exceptions. Out of the set of all the numbers, we have to take out some. Which are the values that we need to take out? Well, this one, the exceptions, right? Take a look at this. Except those for which the denominator Q is 0. So when the denominator is 0, we need to cancel those values. Those values are not good. Let's take a look at this example, guys. We're gonna do the first example, and the second one, hopefully, we're gonna leave it for after the break, right? After the lunch, right? Because if we do, I don't think we're gonna be able to do two examples. All right, so let's find the domain of the first function, the function f, this one here. Okay, so we know the first part. We know the domain of this function will be all real numbers. That is the domain. But we need to find some exceptions. Except one number, or maybe two numbers, or maybe three, right? We need to cancel some values out of the domain. Some exceptions, right? But how do you find those exceptions? Take a look at this. We need to exclude the values for which the denominator is 0. The denominator is 0 when x equals something. When that happens, those are the values we need to exclude. So how do we find the values for which the denominator equals 0? Simple. We take the denominator and equal it to 0. X plus 5 equal to 0. That gives us one equation. If we isolate the value of that equation, right, the positive 5 passes as a negative. If we isolate that value, there it is. There is our exception. We found it. X equal negative 5. When x is negative 5, if I get to change x by negative 5, what is going to happen is that the denominator is a 0. Look, negative 5 plus 5, that's 0. Just like Alba said. Thank you, Alba. That is 0. And that is no bueno. We don't want that. We don't want that in here, right? So the domain here, the domain are all the real numbers except negative 5. That is our exception. That's it. That is it, guys. Domain, all the real numbers with one exception. Negative 5. That's it. Negative 5. All right, guys? Beautiful. Now, some of you might be saying, how do you do it with the second one? I have 2 minutes. I think I can do it. 2 minutes, right? Let's do this one in 2 minutes. Let's find the domain for the second one. Again, we need to exclude the values for which the denominator is 0. Again, we know the domain is all the real numbers with a couple of exceptions. We just don't know what are the exceptions. So we need to find those. Find the values that we are going to exclude, the exceptions, right? And how do we find those values? How do we find those values? Well, we're going to take the denominator and equal it to 0. Look, x squared minus 4. That is the denominator in the second question. So we take that denominator and equal it to 0. Once we isolate the variable, we have those exceptions. That's it. Okay, so let's isolate these real quick. Remember, isolating the variable means we want to move everything else to the other side. Of course, with the opposite operation, right? So in here we have a negative 4, so we move it as positive, right? X squared equals 4, right? Now, this 2 is an exponent, and we wanna move it to the other side. So how do we move it? We pass it to the other side as a root, right? But we remember, hopefully we remember, that roots can be positive or negative, right? So when I move the exponent as the root of 4, we also calculate the positive and the negative root of 4. Huh? Of course, we all know the root of 4 is 2. We all know that. The root of 4 is 2. So in this case, in this specific case, we have 2 exclusions, 2 exceptions. The 2 and the negative 2. So the domain is all the real numbers except 2 and negative 2. That is it, guys. That is how you find the domain in rational functions. That's it. That is it, guys. All right, you guys have any questions about this or not? Did you guys get it or not? All right, Marino got it, Lau, Vale, Juan Camilo Alba Castro. All right, everybody got it now. Beautiful. Thank you. Thank you, guys. Thank you. All right, finding domains is absolutely easy. After we came from the break, I'm going to explain what the hell is this writing. No, what is this? I'm going to explain that when we come back, all right, from the break. So we're going to leave it here, and we will continue when we come back. Guys, go ahead and have your lunch, and we'll meet again at 1:30. All right, guys? Bye-bye. Bye-bye.